this all come together? How would this Nanda architecture come together? There are many scientists, many researchers, many corporate partners, many startups are working on this. And I'm going to hand it over to MIT scientist Pradyumna Chari to talk about the Nanda registry architecture and walk you through the very specific details on why and why not a registry for agentic AI should have certain features. So over to you, Pradyumna.
Awesome. Thank you so much, Ramesh. If I could just share my screen as well. Perfect. Awesome. So it's been such an incredible session so far. I think hopefully people have enjoyed the diverse perspectives that we've gotten till now, all of the demos. I think Ayusha's demo was really uh, perspective changing for me. But yeah, so thank you so much for sticking along. Uh, I think Ramesh started out with talking to you broadly about uh, the goals of Nanda, what the Nanda team is working on. Ayush showed us a very, very good example of of what we are working on the implementation side, with sort of integrating various agent-to-agent interaction protocols, such as A2A, MCP, and then building on top of that to enable agent-to-agent communication, agent-to-tool communication, building of teams to do tasks, and so on and so forth. And the critical aspect that all of this builds on top of is this idea of an Nanda registry. So on top of all of the other work that the Nanda team has been doing, which is organizing the summit, bringing together all of these thought leaders, working on the implementation side, we also have a dedicated group of a very smart group of people from industry and academia working on sort of perspective academic papers. And today I'll be talking to you a bit about two of these papers that we are launching today. Uh, that relate to when do we need or why do we need a new infrastructure for this internet of AI agents, and then our first registry architecture that enables this internet of AI agents. Both of these papers are public right now. You can go to tinyurl, Nanda paper 1 and Nanda paper 2, very innovative naming. And you can go through that as I briefly describe these to you. After I talk, we'll also have some of our partners from industry give us very, very short talks on how they think about the Nanda registry and the importance of it. So first up, upgrade or switch, building the agentic web. So uh, today we are at almost a paradigm shift in how we are moving from what we call the traditional web of static reactive web pages that are stateless, where humans manually navigate with explicit requests. And we are moving to what we call the agentic web, where we expect a bunch of agents to be hosted in a decentralized fashion on this internet of agents and proactively looking to do tasks, finding other collaborators, meeting other agents, continuously learning from interactions, transacting with each other, and just working in an autonomous fashion. Imagine the web that we have, but if each web page was this intelligent entity that can learn, earn, transact, proactively operate with each other. And that's what we are looking at with the agentic web or the Internet of AI agents. So a sort of obvious question that comes up is, can the current web architecture handle this change that's about to happen? What aspects can we retain from the current web architecture, and what needs to be changed to enable this web of AI agents? So as a quick primer, some of the critical aspects of the web architecture that may make or break this Internet of AI agents include addressing systems such as IP, metadata systems, which would be the analog of, as Todd was talking, agent card, and so on and so forth. So the web has an analogous metadata system, which is known as who is, which is of course used for compliance purposes, addressing systems, and then certification systems. So these four things exist in the web architecture today. And these four things will make or break the web of AI agents, the internet of AI agents as we move forward. Let's take a quick primer from history as we moved from broadband and dial-up, so as we moved from dial-up or telephone line-based internet to today's broadband ecosystem. So when the internet was fledgling, when the World Wide Web was fledgling, and we all had telephone lines already in our homes, there was a serious discussion on whether the internet should be piggybacking on top of these telephone lines, or should there be an actual dedicated infrastructure for the web of agents? As we know today, humanity decided, and the great engineers of the time decided that we do indeed need dedicated infrastructure. And thankfully, we decided so because the dial-up ecosystem from before had several limitations, such as temporary connections, network switching based lines, speed constraints, of course, very, very limited bandwidths, uh, and so on and so forth. As we now know, had we decided to piggyback off of the dial-up infrastructure to build the Internet of Web Pages, we would have been severely constrained, and several critical applications such as video streaming and many, many other important things may not even have been possible today. So when we think about this question of whether the existing infrastructure is good enough or whether there need to be some changes, it is it is critical to think about what are the applications that may be necessary moving forward. Uh, Of course, there are critical issues with current infrastructure uh, of the web that may affect the agentic internet as it moves forward. This includes aspects such as latency, security, traceability, verification, and so on and so forth. Uh, and if we just think about scaling the existing web infra to enable the Internet of AI agents, uh, of course, there is going to be critical challenges that need to be considered, such as limitations in IP addresses, the speed of DNS propagation, and the fact that it is pretty slow, and agents may need much, much faster DNS propagation speeds, metadata requirements, such as agent cards, which we'll talk about soon, uh, aspects such as verification and certification, and so on and so forth. In front of us, there are two options. We can either decide to upgrade the existing web infra, or we can decide to switch to something entirely new. Upgrade options may include aspects such as switching to new addressing schemes, such as IPv6, update the content of metadata, such as whois, to include agent-specific fields and fields that are critical for agent-to-agent interaction. Uh, Aspects such as certification and how these certificates may be automated to enable speeds that agents may require, and of course, enable overall automation throughout the infrastructure. But the other option in front of us is not just upgrading, but switching. So can we think of new addressing systems for agents? Can we think of new registry architectures that several of our collaborators are working on with us, uh, including hybrid registry systems that may include both centralized and decentralized architectures, and so on and so forth. Overall, there are several comparisons and considerations to be taken into account while we think of upgrading or switching. Uh, Across all of these aspects, there are some benefits to upgrading, especially in the short term, but in the long term, maybe as we think of how the agentic ecosystem may develop, there is maybe merit in thinking of uh, how we can enable this switch from existing infrastructure to dedicated infrastructure for this web of AI agents. Uh, Overall, what we think is going to be very likely and a future that we see progressing very soon is the idea of a hybrid ecosystem where some components are upgraded, whereas other components are likely to be switched. Uh, and that's what we are moving towards. With that being said, I'm very, very happy to introduce to you our uh, registry architecture that we are thinking of right now, which is of course also described in the paper. And as Ramesh mentioned briefly earlier, the way we are thinking of the registry is a two-layer uh, hierarchical architecture where we have a lean, clean registry that maps agents to agent endpoints and metadata URLs, and then a dedicated detailed agent fact or agent card layer that's a self-described document on capabilities, endpoints, and so on and so forth. And on top of all of this, another thing that we think is going to be very, very critical is the idea of dynamic resolution. Similar to how we have caching, routing, and content delivery in the web page, there is going to be a need of routing and serving agentic applications on this web of agents as scale increases. And this Nanda protocol registry architecture is designed to accommodate all of this. The registry, as I mentioned, would be lean and clean. It would either include a sort of name to URL mapping or a name to metadata mapping. And the metadata or the fact schema, which takes inspiration from work such as Agent Card from Google, uh, is uh, is really supposed to be the detailed information that is going to be used for humans to find agents, for agents to find agents, and to enable several of these critical downstream applications, such as discovery, search, and so on and so forth. Uh, the goal of course, this entire ecosystem is to always be based off of verifiable credentials, uh, distributed and federated trust, with different authorities governing various trust zones, enabling aspects such as reputation, discovery, and so on and so forth. And from the ground up, ensure that it is privacy preserving and resolution is overall privacy preserving. Uh, the deployment models of this registry are hope to be very broad. We view this registry as a quilt of registries almost, incorporating several contributions from partners from industry, both traditional centralized industry partners, which may have their own agent registries, but also upcoming companies such as our partners at Synergetics AI who are working with us to deploy hybrid registries for both including centralized registries with URLs or decentralized registries with decentralized identifiers. The hope is that the Nanda registry is a global quilt, which can allow for enterprise registries to also be part of the registry and control their agents as and when they desire. Overall, this is a very exciting time. And as we build this registry, we are taking a hybrid approach to take this forward, where we are focusing on both upgrading existing aspects of the web infrastructure, but also building critical new aspects, such as this agent facts or agent card metadata, uh, and this two-level registry architecture, incorporating with industry players such as big centralized industry players and players in the decentralized space, such as Energetics, and hoping to bring all of this together under the Nanda umbrella. With that being said, as I mentioned, all of this is based on several papers and several other contributors also who are part of this big team, and very, very excited for all the work that we'll be doing together moving forward. With that being said, I shall now like to invite just a few of the partners to just give a very brief 2-minute talk or 2-minute press slide on how they are thinking of the Nanda registry. So, Rob, if I can ask you to join in and talk very quickly.
Yeah, perfect. Can you hear me?
Yep.
So yeah, at Dell, we look at and we're concerned with the whole infrastructure from personal devices and peripherals all the way through some of the largest storage systems and servers that are built. And so, the big thing with the registry is that ability to be able to discover even our own agents across our large portfolio of products and the ability to move between the intranet and the internet for us to partner and have partner services and enable, our startups, enable other, startups, other competitors, and partners to add on to what we already have and participate in the ecosystem that we have today, right? So we really look at that, and tying that back is this work that we're doing with you all, so we can learn how to do that. The other big aspect that people talk about, or everything that we've been learning here today, there's a lot of unknowns, and that's really what we're here to do, especially with NANDA and the MIT team, is to be able to learn with them, partner with them, and really understand all the different aspects of this. And you really open up that ecosystem to us. So that's why we're really, really happy to be part of this and working with you so closely on it.
Awesome. Thanks so much, Rob. Moving to Rekha from TCS.
Yeah, hi. Thanks. Maybe you can go to second slide. Thanks, Pradyumna and Ramesh, for including us in NANDA. So as all of you know, that TCS, the Tata Consultancy Services, they have majority of they have penetration in majority of industry verticals for building solution for them. And so we are building future enterprise application for our client, which are multidisciplinary in nature, and they are spanning across more than one vertical today. And we soon be building system using network of decentralized agents across organization boundaries. So if you see the promises which we have for our customer, looking at agents which can collaborate across different departments, different partners, because we build system as an integration of different services, different products. So you'll have all kind of agents to interact with each other. And how do we leverage this federated knowledge, which is spanned across different departments, different organization boundaries, to build solutions? So that's the promise which we are holding. And to deliver this promise, we need to design the system which really demands the open protocols to discover, some trustworthiness, integration of those things, orchestration. And we want to do all these things across different supply chains. And most of the verticals which we are seeing the need is in the healthcare, in the mobility, and we want to build some safe and do some internal pilots using such protocols. And TCS is really excited to support and contribute to MIT Decentralized AI program, NANDA. And I have shared a couple of challenges and our thought leadership, that how do we plan to handle such challenges in these papers, what Pradyumna has shared, and please feel free to have a look at that. Thank you.
Thank you so much, Rekha. That's amazing. Next up is Mrinal from HCL Tech.
Pradyumna, if you can go full screen.
Yeah, sorry about that.
All right. Hi, everyone. I would like to introduce myself. I take care of the academic partnerships for HCL Tech, which is the global IT services company. And when Professor Raskar reached out to us with this opportunity, we didn't want to miss it out. Mainly because the main aspect that we thought was it's a very collaborative kind of a initiative where, there are academia involved, startups, and also, industry partners. So this was a great way for us to collaborate, to learn from each other, and to solve whatever, problems that we are facing with our clients. And mainly this initiative, provides a neutral background, which is, one of the key aspects of this project, also with the goal of having human in the loop. This is going to help, I think all the industries across healthcare and fintech, as most of the partners mentioned just now. So HCL is, very happy to contribute, and we were one of the first enterprises to host our live MCP server on NANDA on the launch date. And our team is also kind of, collaborating for the writing group. And also we intend to assign few of our research engineers for the further research. So that's what, HCL's goal towards this partnership is. Thank you very much.
Awesome. And next up, we have Shailaja
Hello,
from the
everyone.
loop. Yeah.
Hello, everyone. So I believe my involvement was essential in shaping the Nanda's registry project, like with a strong emphasis on responsible and ethical consideration. And my team's contribution directly ensured that the registry's design wasn't solely focused on scalability and efficiency, but also deeply embedded with mechanism of trust, accountability, and privacy. So as you can see here, Nanda provides the essential trust infrastructure for billions of agents to interact safely and effectively. And it's kind of inspired by the ethical and responsible blocks of LOCA protocol to create a future-ready framework. And both the papers, LOCA protocol and Nanda, how to build registry to support billions of agents, are closely linked by their shared focus on establishing robust architecture for autonomous agents. And as you can see, there are four key components here, and Pradyuman has already talked about it. We are first aiming to have the lean registry architecture that uses dynamic agent cards for scalable discovery. Then verifiable identity that provides secure identities with credential verification, which kind of establish the fundamental trust between the autonomous AI systems. And privacy preserving discovery mostly implement dual path resolution that protects the privacy while enabling the connections, also addresses one of the most critical concerns in AI systems today. And lastly, adaptive routing, which is very much important, that delivers context aware endpoint selection. So yeah, happy to collaborate and really excited to work with this team moving forward. And thank you, Ramesh sir, like for collaborating with us.
And finally, we have William from Flower.
Yes, thank you. First, I want to give a shout out to the Nanda team for organizing this, and also to my colleague Dimitri, who is the one who has been pushing this forward. You can find his name in the papers currently available by the Nanda team, so I urge you to go and read them. And with that said, I briefly want to mention that Flower Lab hosts the Flower platform, which is made open source, ready to train and fine-tune AI models in a federated way. And for those who are unfamiliar with federated AI, the gist of it is that let data stay local while training AI collaboratively. And this has been very helpful in finance, healthcare, as you can imagine. Regarding the points listed here, we are coming from building the infrastructure to run AI in a federated way. And now we're working closely with the Nanda team to combine both of our efforts. What you can see here is federated query execution, which basically means query execution across decentralized databases and indices. And this is already available through our federated analytics. And Flower is built to be modular. That is why we're also looking into how we can construct federated AI agent registries, something that keeps track of which agents are available for training, what kind of data they hold, computational abilities, and so on. And yeah, this kind of goes hand in hand with the concept of federated agent routing, which someone mentioned before, and it's like a search task, which finding the best agents, and we're looking into this as well. And of course, we try to make this as secure and private as possible. One of these efforts is Flower Intelligence, a local first way of running AI agents with the possibility to increase computational abilities if required through Flower Confidential Remote Compute. But yeah, as said, we're working closely with the Nanda team to make this reality. So feel free to reach out to us if you want to know more.
Awesome. So thank you so much. And there are so many other partners also working with us. This is just a sampling given our time constraints, but very, very excited to take this forward. Of course, the Nanda team is continuing to work on all fronts, including deployments, writing, academic writing, research, and there are several open problems that we are exploring as part of this group. These include at various stages of the Nanda infrastructure, such as how to build better registries, how to build better reputation, knowledge pricing, trust, user interface mechanisms, verification, all the fun stuff that our team here at MIT and as part of Project Nanda as well is very, very excited to participate in moving forward. And yeah, with that being said, I think that covers our research update for this presentation. So thank you. Thank you so much, everyone. So now with this, I think, Chris, I don't know if you're online, but yeah, Chris.
Do you want to take a few questions while you're waiting?
Yeah, absolutely. Any questions in the chat?
Maybe you want to put up the slides so people are.
Will do.
One obvious question that needs to be addressed here, Pradimna, is what does it mean when A2A and MCP are doing a fantastic job on the communication layer? What's the need for thinking about registry, and how does the agent card proposed in the Nanda registry relate to the agent card in A2A?
Yeah, I think that's a great question. So couple of aspects to this actually. So as you mentioned, and as we've talked about earlier, the A2A and MCP are sort of incredible starting points for agent-to-agent communication, teaming, orchestration. But there is a need for these decentralized agents that are available on this Web of Agents infrastructure to be able to see each other, find each other, discover each other, and yeah, work with each other. So we think that the registry is going to be sort of the foundational piece that brings all of these communication protocols, reputation mechanisms, trust mechanisms, all of these applications onto together and like to be able to work in this decentralized Web of Agents infrastructure. And in terms of the agent card and how this works with A2A, I think we are very inspired by aspects within the agent card that's proposed by Google A2A. Important thing to note is A2A is currently a self-declared agent card by the designer of the agent. It's self-declared capabilities and it's meant for human consumption. But as we scale this web of agents, to enable agent-to-agent interactions, there's going to be a big need to make these agent cards more agent-catered, more sort of networking catered, such as aspects such as routing, load balancing, reputation, discovery, and that's where we build on top of the A2A agent card. Awesome. Chris?
And what are some ways people can participate in the paper, in the registry, and so on?
Absolutely. I think we have teams working on all of these aspects non-stop. So we have folks working on the academic writing. We have a big group that meets essentially several times a week to write all these amazing papers. We have industry partners who are deploying solutions with us. We have a coding team. People can help us with project management, coding, writing, communication, basically any skill that you have in this tech space. Nanda is a big project and we can use your skills.